The last type of measure of relative location is called z-scores. So a z-score basically is just the number of standard deviations a data point is above or below the mean. So it just basically tells you where exactly is it in relation to the mean. So one of the things that must happen with z-scores is that the data itself must be normal. So what I mean by that is that the data looks something like, whoa, what happened? It looks like this. So it looks like a bell curve, okay? So if you look at a bell curve, let me maybe make it a little bit bigger. Notice that here is the mean, okay? It's right in the center. What it basically says with the number of standard deviations, so basically let's say the mean was 10. And the standard deviation, right? So that's how far each data point is roughly on average away from the mean. Let's say the standard deviation was equal to, I don't know, 3. Well, if I go 3 units above, I'm going to be at 13. If I go 3 units below, I'm going to be at 7, okay? Notice that this is one standard deviation. Notice that one standard deviation has approximately all of the data, if not most of it. So most of it is there. Now, if I tend to go a little bit further, if I go 2 standard deviations, so now I'm at 16, okay, and then I move 3 units lower, so now here I'm at 4. Well, this is going to be 2 standard deviations, so let me write that down. This is going to be 1 standard deviation, and now here I went out 2 standard deviations. Okay, now notice that anything after 2 standard deviations is not very likely to occur, right? Because most of it is up here, most of it is here. But past this point, well, these are usually unlikely. So z-scores basically are really good to tell me where exactly is the likelihood of obtaining a data point. Later on when we get to probability, you'll know what that likelihood is, but it kind of gives you a crude estimate of what it is. Now, how do we calculate the number of standard deviations above or below the mean? So for a sample, we remember that X bar stands for the sample mean. Here S, or S sub X, was equal to the standard deviation. I'm going to call it sample standard deviation. Okay. So basically, and then X is just going to be a data point. Okay. So for a sample, the z-score is equal to the data point minus the sample mean divided by the sample standard deviation. That's basically what it is for the sample. Now, for this class, or I mean, later on we'll do sample z-scores, but for right now, we are mainly going to be using the population. We're going to assume that I know the entire population. So here are a couple of letters. So this is what we call mu. It looks like a U or like an M. And this is what we're going to call the population mean. Then we also have something called sigma. Okay, and this is the population standard deviation. Okay, so the z-score for a population is equal to X minus mu divided by sigma. Usually this is the one that we're going to be using for the majority of the class. This one there will be some theory that a lot of the theory is derived from this, but then later on we will maybe do a little bit of the sample. But it's the same formula. You're just taking the data point, subtracting the mean, and dividing it by the standard deviation. Okay? So usually all of the usual values lie between 2 standard deviations away. Okay? So any data point that is between -2 and 2 of a z-score is considered usual. So basically, if I have a number line, here's -2 and 2 included, anything in here will be okay. Here you're okay. But if you're outside of it, so if you are more than -2 and 2 above or below, then you're considered unusual. So if you have a z-score that's lower than -2 or higher than +2, then in that case you will be considered unusual, because if you see here in the graph, it's not very likely that this will occur. Most of it will be occurring close to the mean, 1 or 2 standard deviations away. Okay, so it's a very crude estimate. Later on, we'll explain why this 2 really is the reason why we use this 2. So here's an example. So a male has a pulse rate of 52 beats per minute. Okay, so maybe this is me. I'm just has a pulse rate of 52 beats per minute. So males have a mean pulse rate of 67.3 beats per minute with a standard deviation of 10.3 beats per minute. So notice that it says male. So I'm assuming that this is all males. So that's why we're using the population. And for most of the part, we're going to use the population. So the mean pulse rate, so our mu is equal to 67.3. So all males have approximately a mean pulse rate of this. This is the average. Now the standard deviation, so every male tends to be different, plus or minus 10.3 beats per minute. Okay, so that's the standard deviation. Okay, so I wrote that down. So what is the z-score of this male's pulse rate? So notice that he's 52, right? So what is the z-score? Okay, so the z-score will be equal to x minus mu divided by sigma. Okay, x in this case is a data point, so it's 52 minus mu, which is 67.3, and I'm going to divide it by the sigma, 10.3. Okay, so I'm going to put that in my calculator. So I'm going to put 52 minus 67.3, and I'm going to divide this by 10.3. And what I end up getting is negative 1.49, about. Okay, so notice 2 things. One, that it's negative. The fact that it's negative indicates something that is below the mean, right? Because if you notice, this guy has a 52. All males had about a 67.3. Well, 52 is a little bit lower than that. So he had, I mean, could it be abnormal pulse rate? Well, I don't know, but we know that it's lower than most males. Okay, so that's where the negative comes from. Now, is this unusual? So would it be random, or would it be like highly unlikely that I will find a male that has a pulse rate of 52 beats per minute? Well, remember that usual values are between -2 to 2, and negative 1.49 is between that, so it's not unusual. Okay, so it's not really unusual. It's not unusual. Okay, so what does the z-score mean? So what does this 1.49 really mean? Well, remember, if we go back to the definition says it's just the number of standard deviation. A data point is above or below the mean. So we can say that this male's pulse rate, or his pulse rate, is 1.49 standard deviations, okay, below the mean. That's basically what this means. Okay, so he is 1.4 standard deviations away from the mean. So basically, if I take the mean, which is 67.3, 1.49 standard deviations, well, if I multiply 1.49 times the standard deviation of 10.3, I'll get a number, and then when I subtract it, I will get this 52, and you can try that out. Okay, now right before we finish, here are some properties of z-scores. Z-scores are unitless because remember, if I divide pulse rate divided by pulse rate, well, they cancel each other out. So they actually have no units. It's not per minute, it's not nothing. The data value is below the mean, the z-score is negative, which is what we found. If the data value is above the mean, the z-score is positive, which makes sense, right? And the data value is equal to the mean, the z-score is 0. So if I get a z-score of 0, that means that I've equaled the mean because this numerator was just 0. So in class, what we're going to do this problem. So go ahead and try this out. And this is the first problem that we're going to do in class. So your quiz, if you made it towards the end of this video, your quiz is going to be on z-scores. So you have a little clue on what the quiz will be. Okay, that's it.